Okay, so the next part of our lesson on angles and standard position is our reference angles. A reference angle is the acute angle whose vertex is the origin and whose arms are the terminal arm of the angle and the x-axis. So there are three things that are important here. One, that our reference angle is acute. Two, that its vertex is the origin. And three, that its arms are the terminal arm of the angle and the x-axis. Okay, so 1, 2, and 3. Okay, and I just put up here to remind you that an acute angle is between 0 and 90 degrees, but not equal to 0 or not equal to 90. And just as a comparison, obtuse angle is between 90 and 180 and not equal to 90 and not equal to 180. Okay, and in this lesson we will use the symbol theta. It's a Greek letter, and we will use it the same way that we would use a variable, but it'll be a variable that would indicate an unknown angle. Okay, so here is a diagram of the reference angle for 230 degrees, which is 50 degrees. Okay, so the angle 230 degrees is drawn in standard position here. Okay, with these two arms. All right, and remember, your reference angle is acute, its vertex is at the origin, and the arms of your reference angle are the terminal arm of the angle and the x-axis. Okay, which is drawn for you right here. Okay, so one of its arms is the x-axis, the other one is the terminal arm of the angle that we're looking at, which is 230 degrees, and notice its vertex is at the origin. Alright, so how do we know that our reference angle is 50 degrees? Okay, well, what we want to do is calculate the difference between 180 degrees, which is right here, and 230 degrees, which is right here. Okay, so we want the difference between that. So we would go to calculate our reference angle. We would go 230 degrees minus 180 degrees, and we would get 50 degrees. Okay, now there's one other thing that's important for you to know about reference angles, and that's that they are always positive. That's the first thing you need to know. Okay, they're never negative. So reference angles. For each angle in standard position, there is a corresponding acute angle called the reference angle. The reference angle is the acute angle formed between the terminal arm and the x-axis. The reference angle is always positive and measures between 0 and 90 degrees, meaning of course that it's acute. The trigonometric ratios of an angle in standard position are the same as the trigonometric ratios of its reference angle, except that they may differ in a sign. The right triangle that contains the reference angle and has one leg on the x-axis is known as the reference triangle. Okay, and we'll take a look at reference triangle later, but for now, let's take a look at what we mean by the trigonometric ratios of an angle in standard position are the same as the trigonometric ratios of its reference angle, except that they may differ with a sign. So we're going to use these diagrams here to illustrate that. The reference angle, which we will call theta subscript r, is illustrated for angles theta in standard position where our angle is between 0 and 360. Okay, and it can be equal to 0 degrees. Okay, so here we have an angle in the first quadrant. Okay, notice it has the red arrow gives you direction, is telling you it's a positive angle. But also notice that this angle in the first quadrant is also the same as your reference angle, and that's because your first quadrant angle is between 0 and 90 degrees, and so is your reference angle between 0 and 90 degrees. Okay, so for illustrative purposes, I'm going to say that our reference angle is 30 degrees. So in this case, our angle theta is the same thing as our reference angle, which I'm going to say is 30 degrees. Okay. Now, we want to show that the trigonometric ratios of an angle in standard position are the same as the trigonometric ratios of its reference angle, except that the sign may differ. Now, in the first quadrant, they'll have the same sign, okay, for sine anyway, and actually for cos and tan too. Now, I'm going to use sine as my illustration, so I'm going to say, okay, well, I know that the sine of 30 degrees is 0.5, okay, and you can work that out on your calculator. Just make sure that your calculator is in degree mode. And so my reference angle too is sine of 30 degrees, and it also has a sine ratio of 0.5, okay, which we would expect because they're the same angle. Okay, let's take a look at our second quadrant. Now we've moved theta into the second quadrant. My reference angle is still 30 degrees, okay? That means that between the x-axis and the terminal arm of my angle, this measurement here is 30 degrees. So how do we calculate what theta is? Well, we want to know the difference between 180 degrees, which is along the x-axis here, and our terminal arm. Okay, now we know that our reference angle is 30 degrees, so if I want to work out what theta is, then I would go 180 minus 30, and that would give me 150 degrees. Okay, now we already know that sine of 30 degrees is 0.5. Let's calculate what sine of 150 degrees is. Okay, so you get out your calculator, you put in sine 150, and you find that it is 0.5. Okay, so notice it shares the same sine ratio as our reference angle, which is 30 degrees. Okay, and in this case, it also shares the same sine. All right. Okay, so let's take a look at a third quadrant angle. Here is my reference angle now between the x-axis and the terminal arm. I'm still going to call it 30 degrees. My actual angle in standard position, theta, is going from the positive x-axis all the way into the third quadrant to my terminal arm. And I want to know what that angle measurement is. All right, so I know that up to here it's 180, and I want to add the 30 degrees to it to find out what theta is. So theta is equal to 180 degrees plus 30 degrees, which gives you 210 degrees. So let's figure out what sine of 210 degrees is. So you get your calculator out, put in sine 210, and you find that it is negative 0.5. Okay, so notice the ratio is still 0.5, but it's not positive anymore, it's negative. Okay, all right, and let's take a look at our fourth quadrant angle. I'm going to say my reference angle is 30 degrees. My angle in standard position, theta, goes almost a full circle. All right, and I want to calculate what this angle is. All right, and I know that up to here it's 360 degrees, right? A full circle is 360. So I want to find out what theta is. It's not quite a full circle, so I can work it out by going 360 minus 30 degrees, and I get 330 degrees. Okay, and I want to see what the sine of 330 degrees is. Okay, and so I get my calculator out and I find that it is negative 0.5. All right, so take a look. Our reference angle is 30 degrees. It has a ratio of 0.5. Our angle in the second quadrant, which has a reference angle of 30 degrees, is also 0.5. Our third quadrant angle that has a reference angle of 30 degrees is 0.5, but negative this time. And our fourth quadrant angle in standard position with a reference angle of 30 degrees has a ratio of 0.5, but it's negative. Okay, so if we go back up here, you should know what this means now. The trigonometric ratios of an angle in standard position are the same as the trigonometric ratios of its reference angle, except that they may differ in sign. Okay, all right, and in the next video we will do a couple of examples.